There is a pump that runs 24 hours a day, 7 days a week, with zero electricity. It has two moving parts. It was invented before the light bulb. It pushes water uphill for decades without a single dollar in energy costs. Engineers tested it and measured efficiencies above 60%. We did not stop using it because it broke. We stopped because you cannot bill someone monthly for a device that runs on gravity. A pump that never needs fuel does not generate repeat revenue. This is the story of the hydraulic ram pump, the free energy water machine that powered rural America for over a century, and the quiet alliance of electric utilities, pump manufacturers, and zoning boards that made it disappear. In 1796, at his family's paper mill in Voiron, Joseph Michel Montgolfier watched the mountain river churn and set out to solve a problem: how to lift water uphill without fire or labor. That summer, he filed a declaration with French authorities describing a self-acting pump powered by falling water. The patent FR 1796-00123, archived in Ardèche, detailed a device with two automatic valves and a single delivery pipe. Montgolfier's sketches showed water entering a cylinder, slamming a waste valve shut, and sending a surge upward. No external energy, just gravity. And a clever sequence of levers and valves. The idea traveled quickly. By December 1797, Matthew Boulton, industrialist and partner of James Watt, secured British patent number 2207. Boulton's Soho Works diary in Birmingham records experiments with a self-acting water-pumping engine on the River Stour. His patent described a pair of one-way valves and a delivery stroke, closely echoing Montgolfier's design, but built with British ironwork for the mills of England. In his notes, Boulton referenced the French ram of Montgolfier, acknowledging the cross-channel exchange and setting the stage for industrial use. The technology crossed the Atlantic in the early 1800s. On April 3, 1809, John G. Miller of New York received United States patent number 5024 for a self-acting water pump. Miller's patent, preserved in the archives of the United States Patent and Trademark Office, described a piston, a check valve, and a waste valve, clear echoes of Montgolfier's original. By 1810, American Mechanics magazine advertised Miller's hydraulic ram, boasting the ability to raise 150 gallons per minute without external power. Within a generation, the concept had moved from French mill to British foundry to American farm, and the ram had taken root. Throughout the 19th century, the hydraulic ram appeared in engineering journals and municipal records. Technical drawings and advertisements surfaced across Europe and the United States, each new version refining, but never replacing the original principle. By the 1880s, the device had evolved from hand-built prototypes to cast iron machines ready for industry. In 1884, on the banks of the South River in Waynesboro, Virginia, local founders led by the Rife family filed a charter for the Rife Hydraulic Engine Manufacturing Company. The Virginia State Corporation Commission recorded the company's purpose: to manufacture and sell hydraulic engines and rams. The foundry, with its dam and cast iron works, anchored the Rife name in American hydraulic engineering. Over the next century, the company would endure name changes, relocations, and generational handoffs, but its core business, building gravity-powered pumps, remained unchanged. Today, Rife Hydraulic Engine Manufacturing still operates, now in Nanticoke, Pennsylvania, its lineage traced back to the 1884 charter and Montgolfier's ingenuity. The patent trail is more than a record of invention. It proves the hydraulic ram was ready for industry long before electricity, its legitimacy grounded in signed declarations, numbered patents, and surviving company charters. These documents, scattered from French archives to American patent vaults, form the backbone of a technology built to last. Patent records show a continuous practical lineage from the mill at Voiron to machines in fields and towns around the world. A hydraulic ram pump does something that sounds impossible. It pushes water uphill, day and night, with no electricity, no fuel, and only two moving parts. The principle is pure physics, a controlled explosion of water pressure called water hammer. Water flows downhill through a drive pipe, picking up speed. At the end, a spring-loaded waste valve sits open. As the water rushes in, it slams the valve shut. The sudden stop creates a shock wave, a pulse of pressure that forces a fraction of the water through a one-way check valve and into a sealed air chamber. From there, it rises up the delivery pipe, sometimes hundreds of feet above the original stream. The cycle repeats automatically, often once per second. No operator required. The numbers are not folklore. Peer-reviewed studies, including a 2022 article in Advances in Civil Engineering, measured commercial cast iron rams under controlled conditions, with a supply head, meaning the vertical drop from source to pump between 2 and 8 meters. Modern ram pumps delivered between 1,500 and 72,000 liters per day. That is enough to supply a household, a farm, or even a small town, provided the stream keeps flowing. Delivery heads, how high the water can be pushed, regularly exceed 120 meters, or nearly 400 feet, in properly tuned systems. Efficiency, defined as the percentage of the water's gravitational energy converted to useful lift, routinely lands between 60 and 80%. These figures match what engineers recorded in the late 19th century and what modern field tests confirm today. The design's simplicity is its secret. Only 2 parts move: the waste valve, which cycles open and shut, and the delivery check valve, which snaps open during each pressure pulse. The rest is pipe, air, and water. There is no motor to burn out, no wiring to corrode, no bearings to grease. Commercial cast iron rams from the 1880s have been documented running for decades with only routine cleaning. Even homemade versions, assembled from PVC plumbing fittings, can match the performance of their iron ancestors, though they rarely last more than a few seasons before ultraviolet light and pressure cycles take their toll. There are prerequisites. A ram pump cannot create energy from nothing. It needs a reliable source of flowing water and at least a few feet of vertical drop called the supply head. The more water and the greater the fall, the more power is available. But within those limits, the device is self-sustaining. Once set up, it runs until the stream dries or the pipes freeze. The physics are universal. Water hammer is as old as plumbing itself. What Montgolfier did was harness that force, tame it with valves, and put it to work. That work, measured in liters, meters, and years of uninterrupted service, stands up to any electric or fuel-driven pump on the market. In the words of one civil engineer interviewed for this film, the hydraulic ram is the rare machine that, when properly installed, outlasts its installer. The technical record is clear. For any site with flowing water and a modest drop, a ram pump delivers free, pressurized water with efficiency that rivals many modern electric pumps. The only ongoing cost is gravity. And gravity never sends a bill. By the mid-19th century, the hydraulic ram pump had quietly become the backbone of rural water supply on both sides of the Atlantic. Town archives from Naples, New York, record a decision in 1852 to install a 4-inch ram that delivered water to public standpipes and household taps. According to municipal minutes, the installation supplied roughly 20,000 gallons a day, enough for the entire village, fed only by the steady drop of a hillside spring. Local newspapers described the new waterworks as a marvel. No coal, no steam, just the pulse of water hammer lifting clean water above the rooftops. In Illinois, the story repeated itself. Algonquin and West Dundee, 2 small towns along the Fox River, invested in hydraulic rams during the 1890s. County board records and tax assessments list expenditures for twin cast iron pumps, each built for redundancy in case of drought or mechanical failure. Maintenance logs from the period show repairs limited to cleaning valves and replacing worn seals every few years. The pumps ran day and night, filling elevated tanks that fed hydrants and household pipes, their operation so steady that most residents never gave them a second thought. Hoka, Minnesota, turned to the same technology for fire protection. Fire department archives from the early 20th century detail a ram-powered system that kept a 2,000-gallon reservoir filled at all times. Incident reports note that during dry summers when other towns rationed water, Hoka's hydrants flowed freely, pressure supplied not by engines or electricity, but by the relentless cycling of a single ram at the creek's edge. The reach of the hydraulic ram extended well beyond American borders. In France, the device was known as Bélier hydraulique, a name that appears in municipal engineering reports and technical journals from Paris to Lyon. The term Bélier captured both the mechanism's forceful action and its Gallic origins. French patents and trade catalogs from the 1840s through the 1930s list dozens of manufacturers, each touting improvements, but all using the same core principle first described by Montgolfier. Across Europe, rural estates and small towns adopted the Bélier for drinking water, irrigation, and even ornamental fountains. In Japan, mountain villages built wooden and iron rams to move spring water uphill for rice paddies and communal baths, adapting the design to the steep terrain. Technical articles in German and British journals describe the device as indispensable for any site with flowing water and a modest drop. Local historians like Thomas McAllister of the Waynesboro Historical Society point to a simple reason for the ram's popularity: reliability. Unlike steam engines or hand pumps, the ram needed no operator and almost never failed. In archival interviews, residents recalled family farms where the same cast iron pump ran for decades, outlasting generations. Municipal ledgers and newspaper clippings from the golden age of the ram paint a picture of quiet ubiquity, a technology so common it faded into the background, its presence marked only by the steady thump of a valve and the glint of water in a delivery pipe. The story of the hydraulic ram's golden age is not one of isolated experiments or fringe adoption. From the village of Naples, New York, to the hills of France and the valleys of Japan, the ram pump was standard infrastructure. Its legacy lives on in the language of town records, the terminology of Bélier hydraulique, and the memories of those who depended on water that arrived without a bill, powered by nothing more than gravity and ingenuity. In 1935, the Rural Electrification Administration was signed into law, and a new ERA began. Federal funding flowed into the countryside, underwriting the cost of electric lines, and, with them, electric water pumps. County records from Illinois, Kansas, and Georgia show entire districts switching from gravity-powered ram pumps to electric submersibles within a decade. The promise was clear: push-button water at any time, no need for a flowing creek or a hillside drop. But the true price came in monthly bills and a new kind of dependency. The numbers tell the story. In 2023, the global electric submersible pump market reached $13 billion. Industry forecasts project that figure will more than double to $30 billion by 2033. That growth is not driven by technical necessity, but by a business model built on recurring sales, electricity, replacement parts, service contracts, and planned obsolescence. A hydraulic ram pump, once installed, can run for decades with no further purchase. An electric pump, by design, must be replaced every 10 to 15 years. The cycle repeats, generating revenue for manufacturers, utilities, and installers, but not for the landowner. Market incentives shaped what was available at the hardware store and what was left out. Major pump manufacturers, facing a shrinking market for once-and-done hardware, shifted their catalogs and marketing budgets toward electric and later solar-powered units. Trade association reports from the 1950s and the 1960s show a steady decline in ram pump production, even as rural electrification hit its peak. The Rife Hydraulic Engine Manufacturing Company, once one of dozens, became a rare survivor in a field now dominated by electric brands. Regulations sealed the fate for many would-be ram pump owners. In California, the Water Code makes it a civil trespass to divert water without a permit. Section 1052 sets the penalty: $500 per day per violation. The law, originally aimed at large-scale agricultural diversions, now applies to any unpermitted use, no matter how small or self-sufficient. Enforcement records from the past decade show fines levied against rural homeowners for running a pipe from a creek to a garden, even when the water returned to the watershed. In Kansas, state statutes require a formal permit for any surface water use, including on private land. The application process involves engineering surveys, public notice, and administrative fees that can exceed the cost of the pump itself. Water rights attorneys describe a system where even a gravity-fed ram, operating on a trickle, is treated as a consumptive use subject to the same scrutiny as an industrial well. The barriers are not just legal or financial, they are cultural and institutional. Extension bulletins from the 1940s and the 1950s, once filled with diagrams of ram pumps, shifted to promote electric and diesel models. Agricultural colleges rewrote their curricula to match the new reality. Utility companies offered rebates for electric pump installations, but none for gravity-powered alternatives. The result was a quiet erasure. A technology that once meant independence became a legal gray area, a regulatory headache, or simply forgotten. Economists who study rural infrastructure point to a pattern. Technologies that generate ongoing revenue for suppliers thrive, while those that offer one-time solutions fade from view. The hydraulic ram did not fail because it stopped working. It was replaced by a system that made everyone but the landowner money. The story moves next to the people who lived this transition, the farmers, ranchers, and rural families who traded free-flowing water for the hum of an electric pump and a monthly bill. When the grid goes down, the reality of dependence settles in fast. For one homesteader in rural Texas, a winter storm in 2021 cut power for 2 days. The electric well pump sat silent. Pipes froze, faucets ran dry, and water for livestock had to be hauled by hand. Across the county, neighbors lined up at the volunteer fire station, waiting for bottled water. This is not rare. Utility records show that over 1.3 million Americans experience outages lasting longer than 48 hours every year. The cost of running an electric well pump, even in normal times, adds up. Between $300 and $700 per year in electricity alone, not counting repairs or replacements every decade. Solar pumps promise freedom, but batteries fail in cold weather and on cloudy days, and the upfront cost can top $2,000. When the power fails, so does the water. The promise of push-button convenience comes with a silent price: vulnerability built into the system. Rife Hydraulic Engine Manufacturing still answers the phone in Nanticoke, Pennsylvania. Their corporate filings trace a direct line back to an 1884 charter in Waynesboro, Virginia. Family members sign the annual reports, and the company's own ledgers record over a century of serial-numbered cast-iron rams. That living connection is rare, but not alone. The U.S. Soil Conservation Service continues to recommend hydraulic rams in technical bulletins, citing their reliability for off-grid water supply and erosion control. Far from obsolete, the technology is multiplying in places the electric grid cannot reach. In the Philippines, the Alternative Indigenous Development Foundation has installed 595 ram pump systems, supplying water to 300,000 people and exporting the design across Asia and Latin America. At Clemson University, researchers publish open-source plans for PVC ram pumps, tested in field trials and detailed in extension documents. The knowledge isn't lost. It's being passed forward, building resilience, one system, one community, one document at a time. No company holds the rights to the hydraulic ram pump. Its design entered the public domain long ago, free for anyone to use or improve. That freedom is a double-edged sword. Without patents or proprietary parts, there is no ongoing profit, no licensing, no service contracts, no reason for manufacturers to champion a device that works for decades and never needs a bill. In a world built on recurring revenue, self-sustaining technologies like the ram pump are quietly pushed aside. The story repeats itself wherever independence threatens a business model. The more a tool empowers its owner, the less welcome it becomes in the marketplace. Yet the ram pump endures, not because it is profitable, but because it is resilient. When the grid fails or the supply chain falters, a simple device powered by gravity and ingenuity keeps water flowing. The lesson is clear. Technologies that cannot be patented or metered are often left behind, not for lack of function, but for lack of financial incentive. The knowledge remains, waiting to be reclaimed. Today, grid-tied pumps and monthly bills feel inevitable, yet the hydraulic ram quietly proves otherwise. As droughts intensify and energy prices rise, the old designs regain new relevance, resilience that cannot be patented, taxed, or switched off. The knowledge is still public domain, waiting in plain sight. Sometimes what's truly free is simply what we are told to forget. Let me know your thoughts below.